Now departing, the Railway Podcast.
Hello and welcome back to the Railway Podcast special broadcast with me, Ulf Karlsson.
And with me, Staffan Sporre, and this for the second episode from the final event of the FP2 R2DATO in Prague. With outputs from this highly interesting project as part of the information dissemination.
Yeah, in the first episode we learned about the project overview, but now it's time to get nitty-gritty on the details. We're going to hear about the technical aspects of the project.
That we are, and in our upcoming episodes we'll be focusing on research, the supplier, and finally the infrastructure manager and railway undertaking perspectives.
But now, hold on to your technical specification for a peek under the hood. As we say, welcome to Bastian Simoni. Welcome to the Railway Podcast, Bastian Simoni.
Thank you for having me today.
It's very nice to have you. As per our tradition, we would like you to start by introducing yourself.
So my name is Bastian Simoni. I've been working in the railways for more than 10 years now, focusing for the last 7 years on railway automation, everything related to the mainline operations. I have been 4 years project architect of the French project Autonomous Freight Train with SNCF and consortium members. So I discovered all this topic with our demonstrator, our prototyping, our developments in the position of architect. And then later on, I joined Shift2Rail project, so former Europe's Rail, in order to help sharing the knowledge that we gain in this project inside the X2Rail4 project for ATO up to JOA4. I also worked on migration solution for ATO. So typically this was dealt in the Tauro project, with line-side signaling interpretation that you also discovered here in this event, in order to propose migration solutions for ATO on lines, on trajectories not yet equipped with ETCS. And for the last 3 years, I've been involved in FP2 R2DATO as system expert, and also in the system pillar for the onboard. And therefore, I would say that I have quite an interesting experience with ATO, with automation, and also the European landscape.
How much have you been looking forward to this day, to the final event, the gathering here in Prague?
Well, first, I think that this event is very important for the whole community, for the project members first, because this is an important moment for us to show and to share what we have learned, what we have done, but also the results. What are tangible results for the community, but in the end also for the European citizens, because what we do here, this is meant for the railway system as a whole, and also to bring benefits for citizens that are today struggling with mobility. We are in complex geopolitical situations with the fuel prices, with the individual mobility that is today becoming a burden for some people in terms of price. We are in Europe, we do not have oil on Europe, so we have a problem on this part also. So all of this today, I think this is also a strong message to say that yes, we are doing research and innovation for the railways. Yes, this is in the end to bring benefits to the community and to the citizens, and that we must continue in this direction, and of course together, because we are building one railway system for Europe.
So as a system expert then in this project, what has been the major issues for you to deal with?
In my role of system expert, I think that one of the first difficulty that we faced is that the project started with work package that had a different understanding of the overall system we are trying to build. The work package started with reference documentation coming from previous initiatives like the Shift2Rail project or OCORA or RCA or Tauro. And for them, obviously, their source of information was the reference. And they continued in this direction. So one of the first things that we did as system expert is to gather the different work package in order to create a baseline of all the starting points that the people were using, in order to have this shared catalog of baseline 0, let's say, for all these documents from previous initiative, and then to reveal this to the community inside the project, so that all people know, okay, this is the overall starting point of the project, so now we have our baseline 0, and then we can continue. I think this is one of the first problems that we face. The second one or difficulty, let's say, is that as system expert, we switched continuously between system architecture and organizational architecture of the project in order to see what are the links between the work package, what are the dependencies, what are the needs, and how to activate the collaboration. And at first, the project is big, it's a highly integrated project, so we needed time in order to better understand the structure of the project and how we can help as best as we can the work package in their collaboration.
So would you say a project like the R2DATO could help bring different technologies together, bring them closer?
Yeah. One of the major findings that we had in this project is that DATO, so digital, automated, up to autonomous train operation, is a system of systems. This is one of the major findings that we had. So we are capturing a lot of information and we are developing solutions in this project, and solutions that are then serving DATO in a different set of implementation context. We have the urban context, we have the mainline context. Obviously for tramway or for mainline we do not expect the same performance, and yet we can have the same use cases. The remote driving is one example. Remote driving for tramway may not look the same as for mainline. Let's see. Same for perception. Obstacle detection for tramway, this is more on-site operation, whereas for the main line, when we look for ATO up to GOA4, this is obviously not the same level of performance. And so we need to reflect on this, on our work, and how also we can scale the technology versus implementation context, difficulty of implementation and difficulty for also the industry to develop solution technologies that can be inside of a roadmap, I would say, where we can start by quick wins and then go more and more complex, but on the same side for users, also to reflect on what are the use cases that we can implement quite easy in the existing technical system, but also on the existing operational system, because we have people operating the railway system with procedures, with rules. So when we introduce new technology, we need to think about how can I get most of the benefit, but also at an acceptable transition regime for the people, for the processes, and for the operation in the end. Because if I go for a very disruptive technology bringing a lot of benefits, but with a huge transition challenge, it's unsure that I can achieve this on a quick win perspective.
I think someone said that to simplify is the most complex question.
Yes. We are in times where for the railways is more than 200 years old now, so we have a system that has been existing for a lot of time with a lot of transformation. We had telegraphic lines for communication, then we switched to cellular communication, wireless, and so on. So we already faced a lot of migrations in the railway, and yet we are today facing new problems with demographic decline, with pressure on resources, pressure on energy. So these are the problems of our current times, problems for which we need solutions. So again, migration, because we introduce new technology in order to tackle these problems. And therefore, I think we really need to think about this, that the railway is a living system, especially the overall European railway system, and that we are constantly on a migration path. And saying this is one thing, but the other thing is also to look at the targets, because we can migrate and we can continue a road, that's not a problem, but we need to know where we want to go. And this is, I think, also what Europe's Rail is aiming at. System Pillar is defining targets for the overall system, what we call the SERA, the Single European Railway Area. And here in innovation projects, we are infusing technologies into existing trains, existing infrastructure area. So we are bridging somehow the current situation while also looking at the targets of the system pillar, because we are working together. So this is how we can think about all of this, and this is my personal opinion. We can only do this together on an European scale, because we want to have an integrated system. In the end, we are looking for interoperability, we are looking for interchangeability, but also we are looking, and this was discussed today, for resilience and robustness. And for this, we need to have a strong set of suppliers that can deliver solutions in order to support users. We need to have users that are joining forces in the harmonization of use cases so that the supply base, the supply industry can deliver generic products.
Yeah.
And for this, we have programs like this to gather and to converge together.
You're touching on a subject that you mentioned when you're up on stage, a brilliant roundtable discussion you led there, and you talked about the paradox of needing stability but creating instability.
Yeah. Yeah, I think it's worth to mention this paradox on the ERTMS conference of this year, 2026. I heard a certain amount of time, stability, we need stability in the specifications, we need stability in ERTMS in general, and then when we have stability, we can deploy. So I can hear this, because indeed we have been exploring ERTMS and we have been facing some challenges with the deployment, with the error corrections of ERTMS, and yet we are doing innovation. And innovation in its essence is disruptive. But we are not doing innovation because we just want to do innovation. We are doing this because there are problems to solve. And the railway system is facing problems. So I will remind the problems again. We are facing an energy crisis. We need to look for lower energy consumption. We are in a complex geopolitical situation with the supply of components, and we are very vulnerable in Europe. We are also in a situation with an overall demographic decline. So how can we continue to operate a railway system in a context of less and less workforce on the operator side, but also on the supplier side? Because we are all confronted in this demographic decline. So we can say stability, but we cannot blind ourselves and say, no, there are no problems, and then we are stable, but then, okay, we have deployed ERTMS in a super stable way, but in the end, we have no people to operate the system. So we need to find this balance, and I think that we are more and more in the railways, this is my personal opinion, going into the direction of IT. We have an IT system. With digitalization of the railways, this is IT. IT, this is never ending. You have baselines, you have updates of softwares, you have error corrections, you have new features, and the new features are there to answer new needs. And for the railways, I think we need to go into this direction and to find the right balance between, on the one side, the need for stability, but also on the other side, acknowledging the fact that yes, we will be evolving in the railways, like the railways have been evolving for the 200 years. And then the main question is, how can we create a framework in which we can enable and infuse innovation without without destroying or without creating negative impact on the installed base, and protecting the already made investments.
What have you learned as a project member, would you say? What is the most important lesson learned?
What I learned in this project, this is, the first Europe's Rail, this program, this is probably the only place where the overall railway community can gather. So this is where confrontation of ideas, confrontation of perspectives can happen. And this is what I saw in the teams, and this is also what fueled me in some way in the role of system expert, and to better understand. Because the community, the people are coming with their national legacy, their own understanding of operation, railway operation, how their own national network was built, with which technology, which principle. So of course this is shaping perspectives, and this is triggering good discussion, especially when we need to converge. This is what I said today in the presentation. So we can come from different horizons, and yet we are all facing the same problems. So this is the interesting part, and this is what motivates me, because the problems are all networks are working based on national system that are more and more obsolete, and they need replacement. More and more networks are facing congestion, and we cannot, networks cannot build extra lines because of pressure on landscape, and then when you are in this situation, what do? You do signaling instead of concrete. So signaling systems, digitalization, and this is the problem. Demographic decline. This is the same problem for all European members. And so when we come with the same problem, we do not live in times anymore when we can have specific solutions. So we need to come with harmonized solutions. This is what we discuss here, because the industry cannot continue to supply for fragmented markets or fragmented technical solution in the context where engineering workforce is also at pressure. And we are looking for a large-scale deployment. So in general, we need to do for automation what we did for ERTMS, ETCS with a harmonized solution. I think that also one of the biggest learnings inside this project, is that DATO as a system of systems, as I said, and that the idea of target system is nice, but let's be careful, because we can have a target system that can be unique, yes, but the target system will not be the same everywhere, because the needs are not the same. You cannot compare a very busy corridor with a low density line, obviously. You cannot compare depot automation with mainline automation. Contexts are not the same. And therefore, when I hear target system, I think technical configuration. And this is one of the learnings in the team, in this project, that we need to look at technical configuration and some kind of menu. What is the menu for automation? What do I need as a component, as level of performance, as functionality? And then when I know my needs, my use cases, and my implementation context, I can choose from this menu what I want. And this is compatible with the vision of a target system, because the target system can be this menu. As long as I choose what is inside this menu, and this is harmonized, this is standardized, then we are in this spirit. But I think that this is something that is worth to discuss, because when we speak about SERA with target system, I think that for now the understanding in the sector is that we have one system and that's it. And I'm not so sure about this.
At stage you talked about, or you and your colleagues talked about this catalog of artifacts.
Yes.
Is that a means to reach that goal, to have a menu?
That's exactly the idea. So in this project, the teams, the work package, we're looking at the so-called technical enablers, so research and innovation items, and the different teams were producing specification. That is more product-driven and not necessarily system-driven. So the architecture team collected all this information and integrated this information inside this so-called catalog of artifacts. And I said this also on stage, this is not about just taking out the functions, the use cases, the components out of the work package specification. It's also about making a rationalization in this catalog in order to see what could be potentially redundant, what could be better thought in terms of system design, in terms of system architecture, what are open points, what are incompatibilities, because this can be identified at system level in an architecture framework. And this catalog, inside this first project, this FP2 R2DATO project, this is the first version. So this will be available for the public, this catalog, so it's possible to browse and to see what is the collection of use cases, the collection of functions, the collection of components and interface. And out of this, you can create your own system architecture if you want. But as you have chosen the different items from this menu, from this catalog, you are sure to be in a system architecture that is harmonized, because this is the outcome of the project. So there will be no specific items. And this is, I think, what is interesting in this question, to say, yes, maybe the target system is a catalog or a menu of all of these items, the functions, the use cases, the components, and out of this, if I am a user or an infrastructure manager, I have specific needs in my area, then I look in this catalog and I say, okay, I would like this, 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 and this, and maybe this is not the whole catalog, because this is enough to satisfy my needs in order to tackle my problem.
You don't need a plus menu, so to speak.
Well, sometimes, you know, in France we have cheese and dessert, fromage et dessert, but most of the time one of the two is enough.
Yeah.
Yeah. But would you say that this catalog could be a model for all of the flagships in Europe's rail?
Well, here we come on the question of the overall convergence inside the program, which is, I think, a path that is wise to take in this project. First, we looked at R2DATO projects and solutions leading to this DATO system of systems. But the definition of DATO, I think, is something we can discuss. So typically, are all the information coming out of FP1 Motional on traffic management system part of DATO? I would say yes. Yeah. I would say yes. So why not integrating this in the DATO system of system for traffic management system? But tomorrow we may have other technologies. What about also FP6 for regional low density lines? I really think that most of what we did for DATO is applicable to low density. So the same systems, but most probably a very different level of performance in order to make the technology cheaper, accessible for low density, and offering high frequency but low capacity, because this is what we expect for low density.
Would you say the task mostly has been about developing existing technologies, or inventing or specifying new ones, or identifying maybe?
So in FP2 R2DATO, I think that for most of the activities we were continuing, enhancing existing technologies. Why? We do not start from scratch. We start from Shift2Rail, where Shift2Rail was already investing a lot on new technology and how we can enhance railway operations with technology. And besides this technology today, I think the topic is well known. It's well known in the sector, it's well known also by the industry. We have made a lot of demonstration. We have demonstrated the feasibility for the technology and the readiness level. And now, from my perspective, the real challenge is how can we deploy these new technologies in the existing system, railway system. And just imagine, when discussing about FP2 R2DATO, the train from AZD that we will see during the demonstration is a train that is most probably 40 years old. And this train has been retrofitted for up to JOA4. So you see technologies from 2026, perception, sensors, computing platforms, in a 40-years old train, and the same also for the infrastructure, where we can have moving block or hybrid train detection that are plugged into existing interlockings that may be 20, 30, 40 years old, if we speak about relays interlocking, for example, with specific interfaces. And this is a reality that we must face. And I think that now the challenge is about this, about the deployment, about the so-called infusion of the technology in the railway system, and how we can continue this tradition of the railway system to continuously evolve and have technologies from maybe the 70s or the 80s that are neighboring technologies from today's environment.
That's kind of a vision for the future as well, isn't it?
Yeah, well, again, the railways, 200 years old, a lot of transformation. We have known steam machines. We know today very high-speed lines, in-cab signaling, a lot of new technology that we invented. We faced operational transformation already with the introduction of high speed and cab signaling. This was a major transformation for the driver and for the operations. And now we are witnessing demonstration with the remote driving, where the driver is the remote driver is now on the track side. And tomorrow we are speaking about JOA4 or maybe in a larger way automating functions, where part of the life cycle of the train is automated, maybe not 100%, maybe starting of the train, maybe preparation of the train, maybe the start of mission of the train, maybe the movement from the depot to the first station. This is already JOA4. This is not covering the entire mission, but we can consider this as automating function. What about the people? because you still have drivers, you still have people in the control center. So when you start to integrate this kind of technology in order to automate part of the life of the train and to reallocate roles and responsibilities, you will still have humans in the loop in order to ensure that the operations are going well. And for a long-term future, if we are maybe thinking about full automated operations, I think that one of the major questions also was what about the passengers? Today, if you take the automated metro in GOA 4, the metro is running inside the city with high density between two stations that are not so far away and with people from the operator at each station. So if something happens, as a passenger, this might not be very well comfortable, but still you know that there are staff, people that are able to come in order to help you. But tomorrow, for mainline operations, what is the place of the staff in this system? Are passengers comfortable to ride the train full GOA 4? Maybe for suburban operations, why not? For long distance travels, well, this is an open question. So maybe this will be GOA 3. Maybe automation will enable to put the human at the center with staff inside the train to be more available for the passengers, for service, for questions. I think we have a lot of questions that are brought with automation and with the change of operations, but for all of us, for the operators, for the industry, in order to satisfy passengers, which is of course our end goal.
Is it something more that the listeners need to know about the technology? Do we have all the things and the tech that we need? You have talked about it, but there are still some problems that need to be solved. And we have the wave 2. The work is in progress.
Work is definitely in progress. We have the wave 2. I think that what we can discuss about is, again, this word that I love, the convergence. Because in wave 1, for technology, we diverge because we open the horizon for the prototypes with different sensor technologies for perception, different sensor technologies for the onboard localization device, different ways to approach what we call modular platforms for the computing environment inside the train. And this is good because we need to diverge, we need to explore, we need to see what technology and what sensors are relevant for the different applications. And now we start to narrow, we go into this funnel in order to converge and to, retain what are technologies that are, let's say, what are technologies that are answering at best the needs and the challenges that we face, and then also starting to industrialize. We are looking at railway technology. We are more and more looking at component of the shelf, the famous COTS, in order to reduce the cost. And we use also a lot of elements coming from the IT world. And yet, when you want to integrate all of this inside a train, you have very harsh environment conditions. You need to comply to norms and regulations. Just naming the few: vibration, shock, fire and smoke, EMC, electromagnetic compatibility. And therefore, now that we have secured, I would say, some sensors and some technologies in this wave, now we need to secure the rest. So how to industrialize and how to come to solutions that the industry can put on the market.
It will be really interesting to follow this for the coming years. And I'm really glad you took the time to join us at the Railway Podcast. Thank you very much, Mr. Bastian Simoni.
Thank you for having me today.
So that will be all for this episode. Please listen to the following episodes for more in-depth knowledge from this project. Next time, focus will be on the researcher's point of view. Until next time, thanks for listening.
You have listened to the Railway Podcast.